Okay, so now we're actually going to do this problem. So we're going to have to compute the Hessian, which means we need the second derivative. And if we're going to find the second derivative, it means we need the first derivatives. So first, fx is equal to 24 x squared minus 12y, and fy is equal to 3y squared minus 12x. And Brett Wick says yes. So that's good to know. Okay, so then the Hessian, the double x derivative, of course okay. The x derivative, the double x derivative here is going to be 48x. The y derivative of the x derivative, that's minus 12. Since f satisfies the hypotheses of Clairault's theorem, this is also minus 12, which you can see by doing the x derivative of this. And then the double y derivative is 6y. Okay, and if we plug in x is equal to 1 and y is equal to 2, let me just write that's what this arrow means here. X is equal to 1, y is equal to 2. What we get is 48 minus 12 minus 12 and 12. Okay, and then the determinant of this matrix, 48 minus 12 minus 12, 12. This is equal to 48 times 12 minus 12 times minus 12. So this is 48 times 12 minus 144. 48 times 12 is bigger than 400, so this is greater than 0. So the determinant of the Hessian is greater than 0. That means we have a local min or a local max. Now we need to look at the second derivative. The second x derivative is greater than 0. So that means we have a local minimum. Okay? So step one was to see that the Hessian, the determinant of the Hessian, is greater than 0. That means we either have a local min or local max. Then we looked at the second x derivative and saw it was positive. That means we have a local minimum. And similarly, the double y derivative is also positive. So that's another way to see that we have a local minimum. And in fact, if you look at any directional derivative, that is, or if you look at any second directional derivative, that's going to be positive. That means that we have a local minimum. That's just from Calc 1. Remember, this is the second, where are we? This is the second x derivative. It's positive. We're at a critical point. That means that we have a local minimum. That's just like Calc 1. So don't let this be too confusing for you.